Every AI you have ever used writes the same way. GPT, Claude, Llama, Quinn, one word at a time, left to right, never looking back. You give it a prompt, and it types out the answer like a person who can only go forward. It has been the only way we know how to build a language model for years. But what if it did not have to be? What if an AI could write the entire answer at once? Not word by word, but the whole thing, snapping into focus all at the same time, like a photograph developing. That is what diffusion language models do. And this one just caught up to the giants. Here is the orthodoxy. For years, every major language model has been autoregressive. You feed it a prompt, it predicts the next token, then the next, each one locked in, conditioned on everything before it. Left to right, no exceptions. It works brilliantly. But it is rigid. The model can never go back and revise. It commits to each word before it ever sees the end of the sentence. And for years, nobody seriously challenged this because, well, it just works. The question nobody wanted to ask was, is left to right really the only way a language model can think? Diffusion language models ask exactly that. Instead of writing left to right, you start with a sequence of blank tokens, mask tokens. Think of it as pure noise or a page full of fill-in-the-blanks. Then, over several steps, the model refines the positions at the same time, simultaneously, until clean text emerges. Fully bidirectional attention. Every position sees every other position. It is not typing. It is like a blurry photograph slowly developing into sharp focus, the whole image clarifying together, not one pixel after another. The original attempt, Illada, proved this could work at 8 billion parameters. But it was trained on only 2.3 trillion tokens, and it fell noticeably behind Quen 2.57b. Interesting proof of concept, not yet competitive, so the team came back with Illada. Same core idea, masked, diffusion, bidirectional attention, but they scaled the engineering. And the single biggest lever was brutal and simple, 5 times more training data. 2.3 trillion tokens became 12 trillion. That alone accounts for most of the leap. Then the architecture tweaks. They swapped to grouped query attention, 32 query heads sharing 8 key value groups, shrinking the memory footprint. They tied the input and output embeddings together, fewer parameters, same brain. They widened the feed-forward layer and doubled the context window from 4,000 to 8,000. And my favorite detail, they started training with a constant learning rate. The loss plateaued. So they switched to cosine decay. The loss dropped again. No fancy new scheduler, just it stopped working, so we changed it. Refreshingly honest. 2 more things surprised me. First, the super data learner effect. Most autoregressive models do 1 to 3 epochs of fine-tuning. Past that, they overfit. Illada did 12 epochs on the same instruction data, and it kept improving on math, reasoning, everything. Diffusion models apparently reuse data fundamentally differently. If you are training on limited data, that is a superpower. Second, for multiple choice benchmarks, they use a confidence score. Start all masked, reveal the one token the model is most sure about each step, accumulate. It is not theoretically motivated, it is a heuristic, and it beats the theoretically correct method. Simple wins. And the result. Illada 8b beats Quen 2.57b on average across 8 benchmarks, 63.9 to 63.3. It actually wins on math, GSM 8K 81.9 to 79. Versus the original Illada, the gains are huge. Average jumps from 51 to 64. Big bench hard leaps by 32 points. ARC challenge by 25. These are not marginal. A diffusion language model is now genuinely competitive with the autoregressive giants. And that is the real headline. You do not need autoregressive factorization to build a strong language model. For years we assumed left to right was the only game in town. Illada says the diffusion paradigm works, it scales, and with proper engineering it matches the best autoregressive model of its size. The whole page can develop at once. The open questions are big. Can it compete at 70 billion plus? And can reinforcement learning close the instruct gap? But the foundation is now proven. There is more than one way for an AI to think. GPT writes one word at a time. This one writes the whole page at once. That is Illada. Subscribe because the next paper thinks differently too.